Okay, so how about something,
So it's 21 through 30 where we're just doing the odds, right?
yeah, you're just doing the odds. And you can check, the answers are in the back of the book. So you can sort of check yourself that way too. I assigned the odds so you can have access to those to look. Let's look at maybe quickly a couple of these though. How about something like 22? So we want to find here, it looks like the directions are, we want to find the non-zero delta such that epsilon is less than 0.01. Does that make sense? That's what those instructions say, right? Because from our picture, I think I have our picture. Oh, I don't. Let me go back.
So epsilon is just like the function minus the limit?
Right, so I'm gonna pull up a picture. I'm gonna pull up an old,
Basically the delta of
I want introduction to limits, probably that guy, I'm guessing. Yeah, right here. This is the one I want, right? So our formal definition is that we want to be able to show that there is a relationship between the size of the neighborhood of values around x, so we'll call that delta, right? And how close we get to our target limit, call that epsilon, right? So then here's kind of the way the question is phrased, right? Because we know that in general, well, here I have this written down. I'll go back to this one for a second. Oops, this guy. So in general, we know that for every delta that is greater, for every width of the neighborhood, right? So the distance between my x value and c, for that to be less than delta, that has to imply that there is going to be a value of x minus L. There has to be a corresponding value of epsilon. And I should be able to get arbitrarily close, by getting arbitrarily close to C, I should always be able to get closer to L, right? My Y value. We want to make that connection, right? If we look at the language of this, if f of x becomes arbitrarily close to L as x approaches C from either side, then we know that the limit is valid, right? That works as a limit. In other words, I should be able to choose any conceivable target accuracy that I want, any value of epsilon, and I can always get within that target value of epsilon, get that close to my value of my function, the limit, by simply just getting closer to C.
Are you recording this?
I am, yeah, I am. So we want to just make that connection, right? We looked at an example in class, and let's just go back and have a quick look at the one that we did in class. Was something like this. Find the limit L, then find the value of delta such that the distance between the value of the function and the target value, the actual value of the limit, is less than 0.01. So this is just epsilon, right? So that is just epsilon, right? And we're going to find the value of delta. How close do we have to get? How close does x have to be to c in order to make sure that we're within this accuracy of the limit, that my function is that close to the actual value of the limit, right? So all we did, remember, was we just came down and we said, we're going to take the expression, this guy right here, let's color code this. So we took this guy, I guess I did color code it, didn't I? It's the crimson one, right? The absolute value of f of x minus L is less than 0.01 by epsilon, and I'm just going to solve that for x, right? So I want to make that look like this. C is what? Well, C in this case is 2, right? Does that make sense? This is C, and this is L. The limit of f of x as x approaches c equals L. So I want to make this look like the absolute value of x minus 2 is less than delta. Right? I'll see what my delta is. So if I do that, if I go down the process here, if I just do the algebra, 3x plus 6 minus 8 is 3x minus 2, right? What did I do here? Oh no, sorry, 3x minus 6. 3x minus 2 plus 8 is 3x minus 6. I could factor out a 3 and pull that 3 outside of my absolute value, and then just divide both sides by 3, and I got what I wanted. See, I got the absolute value of x minus c, c is 2, is less than or equal to whatever shows up there is going to be delta.
Delta be the one on the very bottom.
Oh, sorry, down here. Right? Because here's my absolute value of x minus c is less than delta. Right? That's the expression that I want to get. Absolute value of x minus c is less than delta. C is 2, so delta is 0.01 over 3. Okay? So that tells me, all that's telling me then is that if I want to get within a target accuracy of my function of 0.01, the width of my neighborhood has to be less than that. I have to be closer than that number to C. My x value has to be, or I wouldn't hit my target accuracy. Okay, make sense? So let's do another one. So now let's go through. Okay. This guy, right? So what is the value of the limit? It's, well, if I plug in 4, what do I get? Okay, so the limit is equal to 2, right? So this is L. What's C? 4, good. C is 4. Epsilon has to be less than 0.01. Okay, does that make sense? Actually, epsilon is equal to 0.01, I should say.
Where'd you get 0.01?
Just in the text of the question, it says, if you read through this, it says, find delta greater than 0, so non-zero delta, such that the absolute value of f of x minus L is less than 0.01. Okay, so that's my epsilon, right? I've got to somehow do a bunch of algebra so I can get this down to the point where I've got an expression that looks like this. The absolute value of x minus c is less than delta, and whatever shows up there is gonna be my delta, right? So we have to algebraically get from here down to there. Okay, so what do? Well, this is totally general. So I have to plug in the specifics for my problem, right? So I'm gonna get the absolute value, what's f of x? Okay, so good, so that's gonna be 4 minus x over 2 minus, what's L? 2 is less than 0.01. Okay, so try that. Take a second and work on that. Yeah, that's good. Yeah.
Sorry, just one thing up there.
Yeah.
You said, is epsilon the function minus L?
Yes.
So
Right.
why'd you put it equal to 0.01 up there, but then you said it's less?
Okay, right, because if we go back, let's look at this guy, right, well, right here, right? Because this is, we're saying that we have to make a connection between, where was that? I keep losing track of where I was on this. Is it right here? No, it was right there. We have to make a connection between these statements, right? So the distance between the function and L is going to be less than some maximum value, epsilon, whenever this is true. Whenever the distance between x and c is less than some value, call it delta, which is the width of the neighborhood, right? So epsilon, this is epsilon, right? We got to be within this range whenever delta is within this range, right? So look at that. Now look at that, right? So this is like saying that's epsilon. F of x, the distance between f of x and L is less than some value epsilon. Well, epsilon must be 0.01. Okay? Mm-hmm. Okay, so what are we going to do? Okay, so subtract 2 from 4, and this becomes the absolute value of 2 minus x over 2 is less than 0.01. Okay, now what? What could I do here? I want to make this look like the absolute value of x minus something. So what am I?
Multiply everything
Okay, well, I could, both of those would work. I could multiply both sides by 2, that would work. But probably better than that, if I want to make this look like the absolute value of x minus something, I've got to factor out whatever the coefficient of x is. So what is the coefficient of x? What's being multiplied by x in this second term? Negative 1/2, right? So I could factor out a negative 1/2, and what am I left with if I do that? I'm going to get x, right, plus, what's 2 divided by negative 1/2? Negative 4. Everybody see that? I flipped the order of those two so I could have the positive first and the negative second, okay? Is less than 0.01. Well, what's the absolute value of negative 1/2? 1/2, right? So I could split this up into 2 separate absolute values, a product of 2 absolute values, right? Because this is true. The absolute value of A times B, would you agree that's equal to the absolute value of A times the absolute value of B? Agreed? So then I can just make this a positive 1/2. Right? Last step.
Multiply.
So same thing as multiplying by 2, okay? So if I multiply each side through by 2, that just becomes that, right? Okay, that fits. You already told me that C is 4, right? And so this matches this, doesn't it? This matches that. C is 4, so what's delta? 0.02.
So when we're answering this, is our answer like a two-part problem where the L and delta?
No, well, yeah, I guess it wants, yeah, you're right, 'cause it wants the limit, right? So you would, we calculated the limit. I think the instructions say technically, find the limit L, okay, so you do that, right? Then find delta. So delta is equal to 0.02.
So on number 23,
Mhm.
it says that delta is supposed to be point, a fifth.
Oh, okay, so I did assign 23?
Yeah.
Okay, let's go through 24. Because that one is, there's something there that's it's a great problem, but there's something that's a little bit tricky there.
Okay.
If I'm remembering which one that is. Is
Don't
that,
worry,
is that a quadratic one?
I believe so. I also
Yeah.
did 24 though, so you can follow.
Okay, so I didn't assign 24.
No, I know.
Okay, good.
It was on the sleep.
Gotcha. Well, that's where you did the wrong one, I got you.
Yeah.
Okay, so 24, same deal. We want to find delta such that epsilon equals 0.01, okay? The function is, we're taking the limit of the function x squared plus 4 as x approaches 5.
Why did I always write X approaches 5 underneath? I'm just curious.
Say it again.
Why did they write the X approaches 5 underneath the limit? Like,
That's just the notation, that's just the way we do it, yeah. Okay, so what is I guess we need to know what the limit is first, right? What is the limit? 29, okay, so it equals 29, whoops, so we need to then start with, remember our goal is always, we want to start with the epsilon expression, right? Our target accuracy is that, right? So in other words, the distance between the value of the function and the limit has to be less than that. Okay, so that translates over to, if we plug in the specifics, the absolute value of x squared plus 4 minus 29 is less than 0.01, right? Agreed? Our goal is we want to make this look like the expression absolute value of x minus c is less than delta, right? So we got to work down to that point. What's our algebra going to do?
Combine the 4 and 29 to make 29.
Okay, so we get absolute value of x squared minus 25 is less than 0.01.
And then
factor.
Oh, okay, we can factor that, can't we? Okay, we can factor the absolute value of x squared minus 25 into the absolute value of x plus 5 times x minus 5. Agreed? Okay, now, talk to me about this. Our goal is we want to make this look like the absolute value of x minus c, which is x minus 5, right? So this is what we need to have in there as x approaches 5. How do we deal with that x plus 5? Any ideas?
I've got a quick question. Why are you not allowed to just take the square root of both sides on the x squared minus 5?
Because that doesn't work. Because x squared minus a squared is not equal to x minus a. The square root of that, right?
But if you took the absolute value of both sides. Like in this case, why can't you just take the root of x squared plus, or minus 25, and then also take the root of 0.01. Because isn't that essentially the equation?
Because the square root of x squared minus 25 is not equal to x minus 5.
But that's why you would take the root on the other side as well, so it's still
Right,
equal.
right, you do. But what's that gonna do for you?
Then you have negative, positive.
See, because we've got to somehow get an x minus 5 there.
Yeah.
And taking the square root of x squared minus 25 doesn't get us to x minus 5,
Oh, yeah. Yeah.
right?
Yeah.
Okay. So this is looking promising, but what do I do with that x plus 5? What do you think?
Can you make two separate,
What can I do? Can I make two separate? We got some ideas going on here.
absolute value?
Yeah, good. Okay, I can split it up.
Yes.
Let's split it up. So let's make this the product of the absolute value of x plus 5 and the absolute value of x minus 5. And so all I gotta do is get that by itself. That looks a little weird, dividing both sides by absolute value of x plus 5. Because you agree, that's kind of what we know what the left side needs to look like. It needs to look like that, and we know that c is 5, right? So we need the absolute value of x minus 5 is less than some number, right? So it would seem to make sense that if I divide each side through, algebraically, that seems pretty good, right? Then we get the absolute value of x minus 5 is less than what, though? How do I deal with that? What value are we approaching on our function? 5. Okay. Right? So in the neighborhood of 5, as x approaches 5, what value does this expression approach? 10. We can do that, right? We can do that. Because as we get arbitrarily close to x equals 5, this expression is getting arbitrarily close to 10, right? Does that make sense? Okay, so this is actually then just becomes 0.01 over 10.
Wait, how'd you get the 10 here?
Because as x approaches 5, this expression becomes the absolute value of 10.
Oh, okay, yeah, that makes sense.
Okay, make sense? And so we end up then with the expression absolute value of x minus 5 is less than 0.01 divided by 10 is 0.001. And there's our connection, right? There's our connection. We wanted to get something like that. Well, there it is. So what's delta? Yeah, good. So if we want the y value to be within 0.01 of our limit, the x value has to be within 0.001 of c. Okay? All right, so questions on that? Okay, so the other kind of question though. So let's do one of the other ones too. Let's see, I gave you, which should I give you from 25 through, I gave you 25, 27.
You go to 31 and then you give us 35 as a chunk.
Okay, good. Okay, good. So I'm not gonna do one like 35 then, I'll leave that one up to you. Let's do, how about let's do two of these, let's do.
On 23, I'm not sure that makes sense, because if you look at the back of the book, it says you're supposed to, it simplifies to 0.01 divided by 5, but I don't see that mathematically making sense, because if you plug in 2, which is the what x is approaching,
Mhm.
then the denominator is 4.
That's what I got too.
And I just like looked through my math, and it seems
Yeah, I don't-
correct.
What did you get from the limit?
So what's the answer? So they say the limit should be,
One.
or delta should be 0.002
Yeah, I know.
for 23.
Or 0.01 divided by 5.
Mm-hmm.
but
Ridiculous.
my, yeah, because my math checks
Oh.
out as 4.
Oh, they messed up.
Aha!
Well, like, what does it mean when they're saying assumed though? 1 is less than X,
Oh, okay.
less than 3. How does that change that? 'Cause that's,
Oh, I see, okay, I see what you're
So they didn't mess up.
doing. No, okay,
is it just a more vague answer compared to
Yeah.
what it is? Is that?
it's, okay, so what they're saying is, okay, so here's what they said for 23. Let's go back to 24. That's what we just did, right? So on 24, if we're in the neighborhood of 5. Okay. So let's just say arbitrarily, let's say our neighborhood is gonna go from 4 to 6. Okay. If we're gonna go from 4 to 6, then if we're gonna go from 4 to 6, then what's gonna be the value in our neighborhood between 4 and 6 that's going to make delta the most restricted? So we want this expression right here to be, as small, to be as small as possible, right? If X is gonna be, we're saying, between 4 and 6, to make this fraction as small as possible, what number would I put on the bottom?
5.996.
So we're gonna, 6, right? 6 would be the answer.
But you can't put 6 if
You
it's
can't
just
put
less,
6, because it's less than 6.
or is it less than or
Yeah.
equal to?
Well, I mean, we're just saying, so what if our upper limit, let's make it this then. Let's make it that,
yeah,
that's fine.
okay.
And we're arbitrarily picking this neighborhood, right?
Okay.
Values.
So
So,
they just arbitrarily picked a different answer?
yeah.
Are you kidding?
Well, no, but what they're saying is, if you make that arbitrary choice,
Yeah.
you're still gonna get an answer that works, right?
Okay.
So, this will make sense. I'm gonna defend why my choice is better.
Yeah.
Okay. So, if we do that, that's gonna give us back an answer of 0.01 divided by 11, right? And that's gonna give us some answer. But ultimately, what is the neighborhood of values? If we want the neighborhood of values to approach 5, then what value would we get for 5, right? We can get arbitrarily close by just plugging 5 in for X. See what I'm saying? It's,
But if we plug it in-
that one's, don't even worry about that one.
Okay,
That's
but-
just, that one's so goofy that it's, because honestly, here's why I can justify that. To me, I think we're not trying to get excellent at doing formal definitions of limits, because we never do. Right, I mean, the goal for me here in the course is I want you to get good at doing the most efficient way of handling the calculus. If you're a math major, you'll go back and you'll look at this formal definition again, and you'll spend a bunch of time looking at a proof of the formal definition, and you'll have lots of fun with that. But in a first year calculus class, you're not gonna do that, because the goal is not to be focused in on this esoteric approach to using limits. What we're gonna do is, ultimately, we're not even gonna use the limits. We're gonna go from using the informal definition of a limit, which is very useful. That's our ant definition, right? If you know that, I'm happy. If you're comfortable with that, that's really what I want you to be comfortable with. Fairly soon, we're going to develop a process of using limits to come up with some more valuable calculus operations, like taking derivatives. That's gonna be the first thing we're gonna do. We're gonna start off taking derivatives, relying on limits to take the derivative, and that doesn't mean anything to you yet, but it will soon. But then our goal is we're gonna try to bypass the limits and come up with a trick, a calculus trick for taking derivatives much more efficiently and easily. So honestly, even the limit part, although it's very useful and I want you to know it, even the limit part is kind of gonna be just a stepping stone for ultimately our goal, which is to be able to do calculus the real way, the calculus way, okay? So, I want you to be able to handle 23, not a big deal. If you can do problems 21, I'm fine. That's good. That's all I really want you to know how to do at this point is can you see the connection between the width of a neighborhood delta and, does this make sense? Does this picture, where's the picture? Oh, it's on this one. It was. It's on this one. Does this picture make sense, right? Does this stuff make sense? That's all I care about is that you realize that in order to, why is that not going all the way out? What? Yeah, boiled again, exactly. Anyway, that in order to get within a certain target accuracy of the limit, we should be able to always get there by just decreasing the size of our neighborhood, getting closer to C, right? That's it. This is kind of a weird algebraic argument, and we could spend all period talking about this, but I don't want to get bogged down with it. Let's just knock 23 off the assignment. If you want to look at it, if you want to do it, that's great.
Actually, quick question.
Great.
Isn't it kind of lazy, arguably, or just blatantly incorrect that they had it just less than 3 instead of less than or equal to?
Oh, I picked the wrong value. It's supposed to be, what was the value of C on that one?
2, I believe.
123.
It was 2, okay, so I think I picked the wrong values. Didn't I say between 4 and 6? I should have said between.
You were doing for that
You were
problem.
doing it for a different problem.
Oh, okay.
But that for 23.
But so for theirs, they had the same exact thing, but instead of having it greater than or equal, or less than or equal to, they had it just less than.
And then use 3.
And then they still used just flat out 3.
Because it was between 1 and 3, right?
Yeah, but they
Yeah,
chose 3.
right. So what they're saying then is, we better do this. Gosh, I hate to spend, oh, well. We better do this.
Well,
So if we're doing 23,
Yeah.
so 23, it's the same, I'm just gonna zip through the first part of this. So we've got the limit of, I want you to understand this. And there's something kind of cool about this. I like it.
but like, if we just made it equal to, then it would just make it at least make sense.
As x approaches 2 is, what, 1?
Yeah.
So then we want to get from the absolute value of f of x minus L is less than 0.01, right?
Yeah.
Okay, so that's like saying the absolute value of x squared minus 4 is less than 0.01, which is like saying the absolute value of x plus 2 times absolute value of x minus 2 is less than 0.1. So then we end up with the absolute value of x minus 2 is less than 0.01 over the absolute value of x plus 2. The problem is that there's this x in our answer, right?
Yeah.
So our answer depends on the value of x that the n is standing on, right? And so what they said is, okay, let's just arbitrarily say that if we're approaching 2, let's just say that the answer can be pinned between 2 minus 1 and 2 plus 1. Right, so let's say that x is going to be on this interval from, what is that, 1 to 3?
Yeah.
Okay. Well, worst case scenario then, if we're going to be on this interval from 1 to 3, what's going to make this function, the neighborhood the smallest, is going to be when x is 3.
But that's
Right.
not, that's impossible.
You're right, but we're just talking about a limit, right? So go ahead and say, put an equal sign there if you want it.
Yeah.
We're just saying, to be safe, I could pick 2.9 infinity, but all I'm really trying to do is say, I want my neighborhood to be safe. I want to make sure that the value of delta I'm choosing is going to get me within 0.01 of my answer, right? Does that make sense? Okay, so then we'll let x equal 3, because we know that's going to be a safe value. If I put 1 in there, I'm going to get a smaller overall fraction, or bigger overall fraction than if I put 3 in.
Right.
I want delta to be always work, so I'm going to be conservative, and I'm going to plug in 3. So that's going to give me the answer. Then the absolute value of x minus 2 is less than 0.01 over 5, right? Which is the same thing as 0.02, 002, right? Which is the answer they got.
Yeah.
Okay, there are an infinite number of answers that are fine. What if I had picked my neighborhood to be between 1.5 and 2.5? Then I would have plugged in 2.5 there. Would it have worked? Yeah, it would've. It would've been
So as long
fine.
as we stay in the neighborhood, we can pretty much.
But
do
it's
whatever
not
we
in
want.
the neighborhood
Yeah.
though, it's not in the neighborhood that they
They were
themselves
just stuck on the last number.
Well, but
Very
that,
stuck on
but that one's just arbitrary. They just said, how far, let's say the ant's only off by 1.
Well, I know, but that's arbitrary, but they arbitrarily picked that area. And then they chose to go outside of that area.
Well, okay, but not really, because what they're saying is, if X is gonna be, if I put in 2.999,
Yeah.
what's that gonna do to the size of this delta? It's gonna make it a little bit bigger, right? So if that works, then 3 works for sure, because right, it's saying that if we look at this picture up here, if this delta works, then wouldn't that one work for sure? It's more conservative, so it's guaranteed to work. All we have to do is come up with a delta that's gonna work, right? See what I'm getting at?
Yeah, okay, yeah, that makes sense.
I mean, it's a little,
It's upsetting, but
it
it makes
sounds a
sense.
little hokey, but there's logic here, right? I think this will help. I just thought of something that I think will help. What if we had picked, this is kind of cool, so really pay attention to this, see if you can get this. If you can get this, this will be a victory, because this is kind of a cool concept. What if we'd instead picked, we'd said, well, what about 1.5 to 2.5? Then the value we would have plugged in there would have been 2.5, right? Agreed? Okay, well, that's gonna give me an answer that's a little bit bigger than this, right? Does that make sense? It would have worked, but for sure, if I pick between 1 and 3, 3 is gonna give me a right answer. Does that make sense? What if we picked from negative, what is this, 2, so negative 98 to positive 100. If I put in a value of 100, that's gonna make this delta even smaller, right?
Are you allowed to think about it?
Well, I could. I know it's gonna work, right? Because that for any value between negative 98 and 100, any value, putting in 100 is the most conservative. So it's gonna give me a really small answer. So it would have been equivalent to like going up to this guy and saying, okay, now delta's gonna be really tiny, but it's still gonna work. Because we made the delta even smaller than it could have been, right? If we wanna pick the delta that's gonna be the least conservative, that's what I did. If we wanna pick the delta that's gonna be the least conservative, what's that gonna be? Well, what value are we actually approaching? 2. So let's make this neighborhood really tiny, right? Let's make the neighborhood go between, let's say, 1.9, infinitely far, infinite number of 9s, or 2.0, infinite number of 0s, 1, right? What value am I effectively plugging in? 2. So 2 is the least conservative value that we could pick.
But it still works.
Right, okay,
Okay.
right, you see what I'm saying
So
though?
the answer really doesn't matter in any way?
No,
it's just
no, but they're all right answers.
But they're all.
They're all right answers, because wouldn't you agree that
Yeah.
if the least conservative value of delta, let's just say hypothetically was 1, then 0.01 is gonna work, for sure.
Right.
It's gonna get us really, right, extra close.
It's 25 through 31, basically, is what you did for 21.
Kinda. We'll look at one of those tomorrow and then we'll start. Okay. Unplanned discussions, sometimes those are the best.